Hello, and welcome to Backer Breaks It Down. In this episode, we are going to look at applications involving compound interest. So take a look at this table. It shows that I deposited $2,000 into four different accounts, account A, B, C, and D. In all four of these accounts, I was paid interest at a nominal rate of 12%. The difference is the compounding period. So take a moment. What do you notice? What do you wonder? So when the interest was compounded only once a year, at the end of that year, I had $2,240 in my account. When the interest was compounded quarterly, so 4 times per year, I had $2,251.02. 12 times per year, $2,253.65. Daily, $2,254.95. So basically, what I notice is that the more often my interest is compounded, the more money I'm making at the end of each year. So they mentioned the nominal rate. They said like 12% interest. Okay. So like I was just making 2,000 times 12% of that added, I'm looking at $2,240. So no matter what, like that 12%, that's a nominal rate. That's like the stated rate. When the interest is compounded more frequently than once a year, the account is effectively earning more than the nominal rate. So when it was like compounded quarterly, monthly, or daily, notice that these values were like more than the 1 year rate or the interest once a year rate. Okay. And we call this the effective annual rate. It's also known as the annual percentage yield or simply APY. So the nominal rate is the stated rate, and the effective rate is like the end result. Like in the end, what is the true interest rate? Think of it that way, the end result, effective rate. Okay. And the significance here. So it says effective and nominal interest rates allow banks to use numbers that look most advantageous to the consumer. So when banks are charging interest, like if you take out a loan, they advertise the nominal rate, which is lower and does not reflect how much interest the consumer would owe on the balance after a full year. On the other hand, with deposit accounts where banks are paying interest, they generally advertise the effective rate because it's higher. Interesting, huh? But in our problems, like the stated rate is the nominal rate and the effective rate, well, that's something we're going to have to calculate. So speaking of calculations, let's talk about two formulas here. We have our compound interest formula. Now our compound interest formula will tell us the balance in our account after a certain period of time. So P is the principal, it's the original amount deposited. R is that nominal interest rate, turn it into a decimal. N is the number of times per year the interest is compounded, and T is the time in years. Now, part of this formula gives us the APY. So like if I were to simply calculate this part right here, that's what we're looking at here. So to get that APY, that effective rate, that in the end, what is my true interest rate? I'm going to take the base of my balance formula, and this is the base. Base minus 1 times 100, sound familiar? But that's how I'm going to find the APY. And the effective rate can be used to compare investments. So whenever you're asked to do that, you're going to use that APY formula. So let's see these formulas in action. So in this, but before we get there, I kind of like dissected an example of this compound interest formula. All right, so here we have the balance is equal to 5,000. 5,000, that's the principal, that's the amount of money I originally invested. Here I have the 0.12, and that's representing the nominal rate of 12%. Remember, the nominal rate is the stated rate. The 4s here, that's indicating that the interest is compounded 4 times per year, which we say is quarterly. Okay, now what I have highlighted there, what I have highlighted will tell us that APY, once we calculate it, so the highlighted part will give me that growth factor, but once I subtract 1 and then multiply this result by 100, I'll get the APY percent rate. Okay. All right, so now let's play around with these formulas. What are the nominal effective annual rates for an account paying 3% annual interest compounded annually, quarterly, and daily? Determine the balance on a $1,000 investment after 4 years. Okay, so 3% annual interest. In our formula for R, we're going to type in on our calculator the decimal equivalent, so 0.03 is what we're going to use. Annually, that has an N value of 1. Yikes. Quarterly, N is 4, and daily N is 365. Okay. They told us we have a $1,000 investment, so that's going to be the original P value. And then when it comes to what is the balance after 4 years, T is 4. Okay. Now remember, in all of these problems, the nominal rate is that stated rate. So for all 3 of these columns, our nominal rate will be 3% because it is the stated rate. That won't change. When it comes to that effective rate, the one and only time it will ever be the same as the nominal rate is in the case of annually. Because if you look at this formula over here, N is 1 for annually, so I'm not really changing anything, am I? Okay. And then I'm going to use this formula to calculate the balance on a $1,000 investment after 4 years. So let's see what it looks like for annually, because I already did the math. Okay, so I ended up with a balance of $1,125.51. And all I did was type the given information into that balance compound interest formula. Okay, so let's check out quarterly. So remember, quarterly is still going to have that nominal rate of 3%, but I will have to calculate the effective rate using the APY formula. And that's what I did here. So over here, you can see that I have for the 3%, I have the 0.03. The 4 is representing that quarterly. So I used my APY formula, okay, and I got an effective rate of 3.034%. So do round your effective rates to 3 decimal places so that they actually do differ from one another. And then for the balance, after 4 years, I'm once again using my balance formula. Okay, but notice this time I've got the 4 here for the quarterly. Okay, and so I ended up with a balance of $1,126.99. And I did the same thing for daily. Okay, so here I have my APY work and calculation. So I ended up with an effective rate of 3.045%, and then using the balance formula, a balance of $1,127.49. Okay. In problem number 2, it says, which investment is more attractive? Okay, so we are going to compare investments, and like it says up above, the effective rate, the APY, can be used to compare investments. So I'm going to calculate the APY for this investment of 8.75% compounded quarterly. So that means for R in that formula up above, I'm going to type in 0.0875, and quarterly means that N is equal to 4. Okay, so that's what I'm using in this formula here. For the 8.7% compounded monthly, I'm going to use R as 0.087. Compounded monthly means N is 12. So I'm going to calculate the effective rate for each of these investments. And here's what I got. So for my 8.75% compounded quarterly, I ended up with 9.041, okay? For 8.7% compounded monthly, I ended up with 9.055, okay? Look at these two rates. These are my percent rates. This one here is bigger. So if this is an investment, clearly I want to make more money at the end of my investment, and that rate of 9.055% is going to do that. So I should definitely invest in the account that pays 8.7% compounded monthly. And those are the basics of applications involving compound interest. So you've got your compound interest formula. This formula here will tell you the balance of your investment after a certain number of years. Here, I'm showing you a breakdown of that formula. Okay, the APY, so the highlighted part, that will get you the growth factor. To get the APY, you want to then subtract 1 multiplied by 100. I'm using this formula here. Okay, that's what's highlighted, right? And there you have it. And that's how Backer breaks it down.